Okay, Ivy, I wanted to talk through the restaurant project real fast. Let's say we found a pizza place that offers 4 different types of crusts, 4 sauces, and 8 toppings, and we want to figure out how many pizzas we could make. I would argue that when it comes to the crust, that you can only have one of them. Okay, so you need to have a crust, but you get your choice out of the 4. So there's 4 things that you're going to do from here. Now with the sauces, what happens here is that you could choose none of them. You could choose 1, you could choose 2, you could choose 3, or you could choose 4 of them. Okay, there's one way to choose none of them. You have no toppings, you're done. You have one way to choose all 4 of them. And so you could have all 4. I mean, it might taste terrible, but you could have all 4 and you'd be done. If in order to choose one sauce, well, there's 4 ways to do that. Okay, you could either have sauce A, B, C, or D. And to choose 3 sauces, it's basically you can omit 1. So you could omit A, or you omit B, or omit C, or omit D. And so there's 4 ways to do that. So with 2, you could do AB, AC, AD, BC, BD. Notice that AB is already right here, and I would argue that if you put one sauce down first and then the other sauce second, it doesn't matter. It would taste the same. And you'd also have, what else did I forget? C, D. So there are 6 ways that you could choose 2 of those toppings. Okay, and so in theory, what we can do here, we can do that same process, or that was for sauces. So you have a total of, what is this? Here's 10, 14, 15, 16. Okay, so you have a total of 16 ways that you can choose your sauces. So this would be, what did we just say? 16 ways total. There's 4 ways here. Now we could do this exact same process with the 8 toppings, and you could say that it's 8 choose 0 is one way that we write that notation. Or we could also say we also often see it this way, 8 choose 0. And this is a combination, which we'll talk about in a second. So you could do 8 choose 0, 8 choose 1, 8 choose 2, all the way up until you get to 8 choose 8. So you need to consider all those possibilities. But notice, if I have 4 sauces, my answer became 16. Well, you might notice, well, let me show you this. This one, if I have, well, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. We're going to talk about Pascal's triangle as we keep going, but notice this row here, 1, 4, 6, 4, 1, and those are exactly the same. And so this row of Pascal's triangle can be listed out as combinations. So the next one, notice here's how we get it. Our outsides are always 1, and then I add these 2, add these 2, add these 2, add these 2. And so this next row here of Pascal's triangle is 1, 5, 10, 10, 5, 1. Okay, so now the cool thing is that if I add this up, I have 1. If I add this whole row, I get 2. This whole row, I get 4. This whole row, when I add those terms, that's 3 plus 3 is 6, plus 1 plus 1 that's 8. We already said that this row is 16. I see 10, 20, 30, 2. Okay, and you might notice that all of these are powers of 2. So this is equal to 2 to the 0. This is equal to 2 to the 1, 2 squared, 2 cubed, 2 to the 4th. So what we could have done here is said, okay, 4 sauces, that would be 2 to the 4th ways that can happen. This, by the way, was 2 to the 5th. So when we want to do the 8 toppings, we could say, well, it's 2 to the 8th. Another way to think about that is that either you have it or you don't. Okay, so each thing that happens, so like when it comes to sauce 1, 2, 3, or 4, you either have it or you don't. That's 2 options. You have it or you don't. You have it or you don't, or you have it or you don't, which is equal to 2 to the 4th. So with our 8 toppings, we could say, well, I either have the topping or I don't have the topping, and this is 2 to the 8th. So hopefully that helps a little bit. Let me know if you have questions.